Hey folks, can y'all see and hear me? Raise your hand if you can. Alright, peachy. So welcome to today's webinar. Thank you for coming out. Few announcements before I get started. We will be announcing the winner of the bridge design competition tonight at midnight. I believe it's via Edmodo. So get excited, we will be announcing that winner at midnight. Are there any questions on anything that we did last class? Alright. Just as a reminder, last class what we did is patterns, so that we could create, give me a second, hang on. You just joined the winner of what? The winner of the bridge design competition will be announced tonight at midnight. And, yeah, that's where we finished last class with Death Star, but, last class we discussed patterns, so we can create multiple copies of something that we made in a either a rectangular fashion, a circular fashion, or via a path that we drew. We also discussed a little bit about grouping, so we can make sure to group things together when we want them to be stuck together, essentially. What else do we do? We also talked about some of the construct functions. Extrude, which will make a 2D sketch into 3 dimensions. Sweep, which had you define a path to extrude a face around. Revolve, which had you define an axis to revolve around, or sorry. Revolve lets you sort of swing an object around an axis to make it 3-dimensional. And we finished up class with the combine tools. There are 3 of them. Merge, which makes objects one solid object. Subtract, which makes holes in objects based on geometry that you define. And intersect, I know we didn't go over it too much, but intersect would only keep the overlapping parts of 2 solids. So we finished last class by creating the Death Star, or a very, very simple version of it at least. So, any questions before I proceed? Alright. The next menu we're going to discuss is the Adjust tool. The Adjust tool has two different options: Measure and Ruler. Now, Ruler is literally what it sounds like. You can click it and apply it to the work plane. From there, what you are able to do, and you're fine, I've only done some review so far. To use the ruler, it follows your mouse until you place it. You must then create click on a 2 or 3D object to activate it. And notice that when I click it, all the dimensions of this object appear. I can also move the object this way. It's a little bit more precise because you can actually see the distance as you move it. And this also lets me move it off the grid or any which direction. Be careful when you use this. If you click the if you click the circle, it will move this ruler around, which might change your design just a little bit. So that's the ruler. The other option, the first one, is the Adjust tool. So I said here to measure your Death Star, but I'm not going to have you do that unless you have it already created. So what we're going to do instead, I'm going to have you just draw a couple very simple objects. I want you to literally just draw a box, create a box via the primitives menu. and then create a sketch circle on top of it. We can then extrude this circle downwards to make a hole in the box, and then hit enter. So the measure tool is really nice because it can measure all sorts of different things for you. Like the ruler, it can measure distances between objects, and I see what did you hit again to make a hole. I go to construct and then extrude. Yeah, no problem. So measure is pretty cool because it lets you measure distance or area of a face or even the volume of a whole object. You see this nice menu that pops up here. All we've got to do is click once on our object, and suddenly the area and the volume of the object appear. And by area, I mean the surface area of this box with the hole. If I click a different object, it will also tell me the area and volume of that object, as well as the distance between the two. So it's pretty handy to have. It'll also show you an angle, if there is an angle that is involved, which there is not in this case. This is just a really handy tool to have so you can perfect your design to the exact specifications that you're looking for. Alright. So it's very handy stuff here. Now let's see where I'm at. I talked about the ruler. And that's actually the last of the second lesson here. So we're going to start on the third lesson, which is a lot more sketch-based than the previous lessons, which were more solid-based. So the first little bit I'm going to go fairly quickly through. We're going to go to the sketch menu. First thing we're going to talk about is these first four options here. We've already used these, hence why I'm not going to spend too much time on them. To use these objects, you have to first click on a plane that you want to draw on, and then it'll draw the respective rectangle, circle, ellipse, or polygon. So, nothing too crazy there. The next option that appears in the list that we haven't really discussed so far. Actually, hang on a second. Did I skip something? No, I didn't. Alright. Is polyline. We've done a little bit with polyline already, so you know how it works. The option beyond that one is spline. S-P-L-I-N-E. Anybody know what a spline is other than what I have written on my screen right now? Alright, I would hope not, because it's kind of a complex mathematical equation thing. If you did, great. Basically, a spline is a smooth curve. The tool itself is very similar to the polyline tool, except the line is dynamic, meaning that the line will move to be a... Let me show you, actually. It's easier to just show you. So we're going to draw it on the work plane just like before. Just like with the polyline, we're going to click to specify the first point, and then click again to specify the next point. Now what this does actually, it has these 2 points defined, but the line moves to create a smooth, straight, or smooth curve rather than these sharp polylines did. So we can keep specifying points, it'll stay a smooth curve for every single point that you choose. Yeah, spline's a lot of fun. You can draw some really cool stuff with spline. But, yeah. The next option we come to is the 2-point arc. The 2-point arc works, once again, you have to define your work plane. The first point you choose will be the center point of your arc. The second will be your radius. Once you click the second time to define your radius, if you move your mouse around, you can pick how long you want your arc to be. So for 2-point arc, you specify the center point and 1 end point. Now the next option is actually another arc. It's the 3-point arc though. So just like before, you have to click to define your plane, but this time instead of defining your center point, you're actually going to be defining your end points. So I'll pick this right there to be my first end, this right here to be my second end, and notice you can adjust how big your arc is just based on these 2 end points. Like a jump rope. So again, I know I am going a little bit fast. I will do a poll in a little bit to see how my pacing is doing. Alright, Sam. Go deal with that bug. Alright, the last 5 options of sketch are sketch fillet, trim, extend, offset, and project. These options actually mean that we have to already have a sketch drawn. So these are just options to mess with the sketch. So the first option, sketch fillet, lets you draw fillets on an object. So a fillet is a rounded corner or an edge of a design, and they're very, very important when you're doing mechanical design. And I'll nerd out about that in just a second here, but if we had a polygon, here is what it would look like with fillets. So just a little bit of a rounded edge. I don't know if anyone's going to know the answer to this, but is anyone familiar with why we use fillets? Why we like to round off edges? Anybody have a guess as to why? If not, it's totally okay. So you can connect other pieces. Not quite. I'm sure a fillet would help for that, but it's not quite what I'm going for here. But good guess. To make it safer, yeah, we're getting closer. I'll just go ahead and let you know. In mechanical assemblies, sharp corners cause a lot of, or deal with a lot of stress. There's called, oh, you killed a stink bug? Oh, you fool. I'm sorry. Good luck, Sam. In mechanical assemblies, we don't like the sharp corners because there's a lot of stress that accumulates in the sharp corners if you try to move or bend the object. This will break the object, and it's not very safe to have an easily breakable object. So if we round out these corners, the object will not be experiencing as much stress on that corner. So this is just me going crazy because I love engineering. Well, the sharp corners will sort of become blunt over time, but I'm not so much talking about in this case. I'm more talking about something more like this. So piece of paper maybe, rounded corner, and then a sharp corner here. Now when you apply pressure to this piece of paper, stress is going to accumulate in certain places more than others. So notice on this rounded edge here, we see blue and green. That means that there's not very much stress being experienced on this portion of the design. But there's a lot of stress being accumulated here. So we like to use these nice rounded corners. This isn't a very good example of a fillet, or of what we'd use fillets for. I'll actually show you what we would be a little bit more appropriate for it. Alright. Oh my goodness, my sketches are so messed up right now. Doop. Doop. So let me show you. They would use fillets more in assemblies like this. Oops, wrong way. I don't know why it's not letting me. Oh, that's why it's not letting me do it. Ah. I'll just stop talking. So that's why they have different options for fillets in this software. So I'm not going to have you do this on your own. Just listen while I talk about this. Trim is basically a fancy eraser. I don't know why they included it, considering it's a little bit easier to just select with your mouse and hit delete. So don't worry about trim. You probably won't use that, but extend is pretty cool. So let's say we have a polyline here that's almost entirely a rectangle. The extend tool lets you extend the line to the closest intersection. So again, I have this almost rectangle. If I select the extend tool and I hover my mouse over this short line segment, a long red line will appear until it reaches this intersection point. Once you hit the green check, you'll have a full box. It's a good way to close open sketches, an open sketch being a sketch that looks like this. It's like a lighter blue than just the work plane itself. That's another one we won't use too much of. The next option is going to be offset. What it does, it creates an identical outline of an object, but it makes it a little bit bigger or a little bit smaller. So if you have a sketch drawn and you select the offset tool, you can click on your sketch. If you move your mouse, you can in real time see the offset. And by that I mean this red line that appears around it. That's where your offset's going to be placed. Does anybody want to guess what would happen if I tried to extrude this area in between the offsets? Any guesses here? Nobody has a guess? Alright. It'd make a pretty cool looking hollow tube. The last option is called project. Project is a little bit weird of a tool, and I'd probably never ever use this in real life. What it does is it casts a sort of shadow of an object's face or an edge onto another surface. It's a little bit weird though because it only sees the object with its point of view. Meaning, right here we have a rotated cylinder. The face of this cylinder is being projected onto this. But if we had a cylinder standing straight up, you can project it onto this box here and it would just make a line. Yeah, I would never use it really. I can't even think of a situation where I would want to use it. I'm sure more complex assemblies, it would be nice to have this, but I don't really know why I spent time writing these slides, because they're kind of, that tool's kind of weird. Oh, my cat just walked on the keyboard again. Maybe when watching TV. I mean, I don't even know. You finished your rhino? Awesome. Okay, that's what I thought, Enmodo. So again, I'm not going to talk anymore about project. It's not the coolest thing in the world. At this point, though, we are able to create an Allen wrench. That's what we're going to be building for our project today. There is a big thing I have not talked about yet that we need to know how to do to build this Allen wrench, and that is sketching on different planes. So by default, 123D likes to draw on this work plane here. So, you know, we place primitives, they're set on the work plane, all is great and well. But what happens if we want to sketch not on this work plane? What if we wanted to sketch maybe there have been more shapes added to primitives? Is there a new version that came out or something? Because I haven't really seen anything about it if that's the case. Huh. I guess some versions might be updated in terms of shapes. That's weird. I'm not entirely sure what's going on. But I'm jealous that y'all have updated it, but I suppose just experiment with those, but on your own time, since I don't have the option to see that. So what if I wanted to draw perpendicular to this bottom face? Anybody have any ideas of what we could do? A wedge, prism, pyramid, and a hemisphere. Oh, thank goodness they finally put pyramid on here. Any guesses as to how we would draw not flat on this work plane? Alright. Because we do need a way to do that. We do need a way to make these sketches. And I know it's a tricky question, and so what I want you to do is start a new design. So you can delete everything else you have on there unless you want to keep whatever design. I do want you to start a new design and put a single box down onto the work plane. The measurements don't matter because this box is sort of a dummy. We're not going to be keeping this box. It's just there to help us out for now. Yeah, I think the default's 20 by 20 by 20 millimeters, so. What we're going to do is we are going to move to, or go to the sketch menu. So if you look at this Allen wrench here, you can tell that it has a cross section of a hexagon. It's basically just a hexagon that has been lengthened. So we're going to go into the sketch menu, and we're going to sketch a polygon. I'm going to click on Sketch Polygon. Notice that your mouse now says, click on Grid, Sketch, or Solid Face to start sketching. What we've been doing so far is just drawing on this work plane. But if I hover my mouse over this side of the cube, notice that the work plane changes. So let's go ahead and click on it. And once we do that, our work plane looks like this now. It's now telling you to specify the center point of the polygon, so notice that you can place it anywhere. I'm going to go ahead and exit it. You don't have to do this right yet, but now check it out. I've drawn these polygons in the air, not on the work plane. Alright, so for an Allen wrench we are going to need a 6-sided polygon, so make sure you do it 6 sides. I would have you, or I want you to make a polygon that has a radius of 7. So 6-sided polygon sketched onto one of the sides here with a radius of 7 millimeters. So at this point, this box is kind of useless. We don't really need the box anymore. You can throw it aside or delete it. We're just not going to need it when we're building this. What we're going to be focusing on is this nice sort of floating in the air hexagon. We've already discussed our next step in doing this. We want to build something that will make the polygon extrude up and then across. So we need to use one of the features that we've learned about already. Does anybody want to take a guess how we could make it so that this polygon moves in a right angle, or any angle? How do I extrude an object? I see modify. You can do that, but I was thinking of something different here. It's going to be in the construct panel. Which option in construct could we use? Sweep, you got it. Does anybody remember what we need to do to start sweep? You could do extrude, but it would only go in one direction. What do we need to use sweep? We have an object. What else? I mean, you can sweep a solid, yeah, but I'm looking for a different thing. Okay. we need to draw a path first. Alright. So we've got this, we need to draw a path. What I want y'all to do, I want you to click on top view for your on your navigation cube. And yes, I did say radius is 7. I want you to click on top so that we're viewing our hexagon from the top down. Remember, this is literally a sketch, so it's only 2-dimensional. It looks just like a line from this view. What we're going to do is sketch a polyline now. So let's go into the sketch menu and then go to polyline. You're going to want to click on the work plane. You're not going to click on the sketch. You want to click on the work plane. Anywhere. We're going to start roughly beneath the polygon. And we're going to want to draw a very long line with a length of 50 millimeters and an angle of 180 degrees. And I'll say that one more time in just a second. Our next point is going to be 25 millimeters long at an angle of 90 degrees. And then we can X out of that. So I'll tell you that one more time. We're going to draw a first line of 50 millimeters long. I guess I should edit this. 50 millimeters, 180 degrees. And you're fine. The next one will be 25 millimeters long and 90 degrees. You know, something looks like this. We can then use the sweep function just like we used last time. We define our profile, which will be our polygon. The first length is 50 millimeters. So our profile is going to be our polygon. Our path is going to be our path. Our polyline is going to be our path, sorry. And here we go. We have a very decent looking Allen wrench here. So remember to delete your polyline as well as the hexagon sketch when you're done. And now let's compare what we just drew to an actual Allen wrench. Alright, so again the steps are, you've drawn the polyline, you'll then need to go to the construct and then sweep menu. Your profile is going to be the hexagon. Your path will be your polyline. So if we compare these two, how do you... Okay, I see a couple questions here. How do you stop drawing the polyline? There should be a green check box. You can click that, or you can hit the escape key on your keyboard. It said invalid operation for profile being hex. Make sure that you selected your hexagon correctly. If you don't have it selected correctly, it might just be thinking you want to select an edge of it. Also make sure that you're drawing on the correct planes. Make sure that your polyline's on the workspace and your face is coming out of the workspace essentially. Alright, good point. When defining the profile, you can click on the white dot in the center of the polygon, which I've erased the sketch of, but that'll definitely work. So how can we improve this Allen wrench? They look a little bit different, my version and this version. Obviously the measurements are a little bit off, but this is supposed to be a very simple, basic example here. What could I improve on this Allen wrench? It needs to be rounded off. Exactly. You got it, Wyatt. Now, how do I round it off? What's it called when I round it off? We went over it a little bit earlier. Fillet. You got it. We can add a fillet to this. There's actually another fillet option. It's contained within the Modify menu. The Sketch fillet, which is in the Sketch menu, only works on two-dimensional objects. Now if we go over to the Modify menu and the center object, or the center option we can choose, is the fillet option. So we can go ahead and click on that. And while we could spend a lot of time, trying to fillet the correct areas, I'm just going to make it simple for you. Yeah, you're right. A lot of these things do have keyboard shortcuts. For example, fillet, you get by hitting the letter E on your keyboard. Getting good at these shortcuts will help you in the long run, but it's not completely necessary to get a hang of it. It'll be nice to know, but not necessary. Anyways, what we're looking for here is to round off this edge on the corner here, and then the inner corner. Now let's give that fillet a radius of 3. And now we have a nice little fillet. You have to kind of be a little bit careful with fillets though. If you make your fillet radius too big, it will completely change the shape of your object. This is a radius of 15 on the object on the Allen wrench. Looks a little bit weird, don't it? Alright, cool. So now we have, other than the material, which I haven't changed, which I'm not going to worry about, other than that, we have a very nice looking Allen wrench here. There's more stuff we can do to it. We can fix the size of it, change the material, yada yada yada. But it's a good baseline. I do want you to go ahead and save it as your name and then Allen wrench. Make sure again to save it to your computer. And then we'll talk about some more advanced options. You're going to want to do fillet, not chamfer. They're a little bit different. We're looking for fillet though. What radius? 3 for the fillet. So I'm going to talk a little bit more about this modify menu. How are we looking on time here? Alright. I'm just going to have you listen while I speak. Maybe if we have a couple extra minutes, I'll let you do some experimentation with this menu. This is the one menu we haven't really messed with other than the fillet that we just did. This is really, not really, but it's a bit more advanced. Some stuff that you probably wouldn't need to use very often, or there are other ways to do it within the software. But it's nice to use if you're doing this a lot, if that makes sense. So the modify menu has a whole bunch of different options. Obviously this is going to be all for three-dimensional objects. The first is going to be press and pull. And actually no, this is going to be the one I do have you do. The rest I'm going to just talk over. Press and pull is a little bit weird. It lets you extrude in 3 dimensions. Oops, hang on. That's wrong. It's basically just the extrude option. Now, when I was making this presentation earlier today, I was very confused. I'm sitting here like, hey, why do we have all these buttons? Why do we have both an extrude option and a press pull option when they do almost the same thing? They actually behave just a little bit differently. And it's very subtle. It took me a good half hour to figure this out. Press pull keeps almost everything the same except for the objects that you're trying to mess with. And that's very vague, so let us give it a try. I hope you've saved your Allen wrench, but you can do it on the same work plane as that one if you'd like. So real quick, I'm going to go ahead and sketch a polygon on the work plane. So doesn't matter what size it is, doesn't matter how many points there are. And I want you to extrude it. So all we're doing now is sketching a polygon and extruding it to make it three-dimensional. So let's go into the Modify menu and click on Press Pull. And let's click on two of these faces. Let's make sure they're next to each other for now. You'll notice that an arrow appears, and then we can pull this arrow. So when we pull this arrow, notice that it elongates the shape, but keeps almost everything else the same. It's just these two sides here that are different. If we were to try the same thing using the extrude function, what's that now, Brendan? Oh, okay. That'll be awesome. So if we try to do it in the using the extrude function, first we'd have to do it in 2 steps because we can only extrude one side at a time. But secondly, this is what would happen if you use the extrude function to try to do the same thing as this. So notice that it's just a little bit different here. This is basically extruding the whole body. This is just extruding the sides. So it's very, very subtle difference here. For most of the things that we're going to be using, or that y'all will make, you won't need to worry about press pull, but it's still nice to have. The next option right beside press pull is tweak. So tweak actually lets you modify the shape of a face or an edge of an object, but not every face or edge can be tweaked. So I'm just going to show you real quick. I'm going to try this. I know it's not going to work, but I just want to show you, for example. Why is it not working? What is... I swear, it only doesn't work when I'm teaching. There we go. So you can basically just tweak little portions of it. It's not for changing your whole design. It's just if you want to make it, you know, bigger or smaller or something like that. You can't do this to every single edge though. It'll be like invalid operation, So you do have to be a little bit careful when you try to tweak. See, it's not liking what I'm doing right now. So the next one in the line here is called split face. It sounds really violent and painful, but it's not as painful as it sounds. Basically what this does is it lets you make one of your faces of an object 2 faces. So what you would do is you would sketch on one of these faces. Just from one end to the other. And then click on Split Face. The face we're going to split is the one we just drew on. The splitting entity is going to be that line. You'll see a red plane show up if you have a valid face to split. And when you hit enter, it looks like nothing changed. But it did. Maybe. Yeah, there we go. Notice that now you can select these individually. And I could, from here, extrude or do whatever I need to. The split face is pretty cool. Yeah. So the next option is Chamfer. Chamfer is sort of like Fillet, except it makes a flat surface instead of a curve. So let me just show you real quick. Again, I don't want you to emulate this, just in the interest of time. So you click on it, you click on an edge that you want to chamfer, you select a distance, and check it out. It just sort of adds more or less area to it. This is more used for aesthetic things, not so much for, mechanical building. So my next option, Split Solid, is just the same thing as Split Face, except it's for the solid itself. So you can split the entire solid in half. The last option here is Shell. Shell will let you make your object just the skin of the object you made. It's a little bit weird. It's used for like stress analysis, but it's another way that you can make holes in things. There's a couple more things you can do with it, but at this level I don't think you're going to really need to know how to do it. And that actually, I believe, concludes our 1-2 3D design section. But Miss Saunders, what does that mean? That means I go to the next lesson. I know it's the end of class, or getting near the end of class rather, but next week we are going to be working with another one of the 1-2 3D softwares. It's called Make. So it's funny because Brendan actually had just been talking about it. Now Make is pretty cool. Not going to talk about that yet. It lets you sort of... Let me start over. We're going to talk about laser cutters. It will correspond with Make, so don't worry. It's not like I'm just talking about this for no reason. Laser cutters do exactly what they sound like. They cut with a laser. Whoa. Crazy, right? These guys were made in 1965. Oh, okay, I didn't know you were talking about something else. It just happened to be the same name. Cool. They were pioneered in 1965 and used to cut holes in diamonds. They can cut holes in a lot of different things, which I'll go over in just a second here. There's a few different kinds of lasers they use, or laser cutters that they use a lot today. The most common of it is a carbon dioxide laser. They use the carbon dioxide to pump through the laser's nozzle, which I'll go over that in just a second, don't worry. Laser cutters are nice because they are precise and versatile, more so than other known methods. Yeah, laser cut ribs. Raleigh folks know what's going on there. Laser cut. So laser cutters are they're simple, but they're weird to understand, sort of. Laser cutters essentially have a beam of light, the laser beam itself, and they use mirrors to bend the light and bounce it until it's very, very focused. But that's not even focused enough. We then have to focus these guys more with lenses. So just like you see with your glasses, they make it clearer for you. This focuses the light so that it is clearer for the cutting, I suppose. This laser then heats up the metal pretty good and cuts it. Now, the gas has two different uses when you push it into the laser cutter. The gas can be used to ignite. It'll get really hot when the laser touches it to help it cut through tough surfaces better. Or it can be used to just blow away shards of metal that are as a result of the cutting process. There's a couple different kinds of these laser cutters. First is called, it's really, really focused. Like, I really can't even comprehend how focused it is. Anyways, couple different types. There's vaporization cutting, which will melt stuff and cut it, just like metal. There's also melt and blow, which will melt it and then blow it away with air. So that's, for example, what the carbon dioxide would do. Thermal stress cracking, it heats stuff up to make cracks. This is mostly for glass, though. Keep in mind, laser cutters can cut many different things, not just metal. Stealth dicing for computer chips, like the really, really tiny ones. We don't really know why it's called stealth dicing. It's kind of a really cool name for something like this. And then we've got reactive cutting for really thick metal. So when the laser cutter senses something is going to be tough to cut through, it will compensate. So laser cutters are pretty cool. They're relatively cheap and relatively easy to use. They can make cuts that are very tiny, and they're useful for very many materials, so glass, metal, cardboard, and wood. We're actually going to be using cardboard for this. Now, check out laser cats. These are the reason laser cutters exist. Not really. But it's a cute picture, so whatever. So 3D modeling has been really nice because we can 3D print it, and we can also machine it via CNC machines. So that's, your lathe, your mill, technologically advanced machining things. But if we only have, say, cardboard, like we will with a laser cutter, we would use make for it. So with make, if you remember from the beginning of talking about 1, 2, 3D, if you have an object selected, you can actually send your object to make. What make will do is slice up your object to a whole bunch of different layers, places them all flat, you cut them out and put it together like a puzzle. So for those in Charlotte and Harrisburg, I think that y'all will be doing this within the next couple labs. For those in Raleigh, we do have that one lab session where we'll be going to Charlotte one weekend to mess around with this. So that's going to be in December, I think. So we'll be working a little bit with that next week. Then we'll start working with the pies some and some Python. It's going to be great. So it's about to be the end of class here. So does anybody have any questions on anything we did today? If you do not have any questions, you are free to go. If you do have questions, though, I will be here until there are no questions. So thanks for coming out, y'all. Alright, what you say? How'd they name the stealth laser? Makes loud noises. I think we should call it a stealth dicer. That's actually probably not too far off. Alright, y'all got anything else for me? Alright, then I will head out as well. Thanks a bunch, guys, and talk to you on Monday.